Hello students, together we go with the fifth episode on alcohol, phenols and ether. Today we are more to the phenols. Let us see how we are going to tackle the entire chapter of phenol. First to go is the nomenclature. Second, the preparation. Third, the physical. Fourth, the chemical property. And finally, the uses. So student, let us go together again with phenol, saying with nomenclature first. Here we go. I have a cluster of 13 such kind of phenol and the derivatives of phenol. Let us see their structure vividly and understand them with the common names and the IUPAC system of nomenclature. So here we go. So when this phenol, you know that they are formed by C6H5OH. Usually we call this as carbolic acid. So student, you might have heard the name carbolic acid. Usually we just spray it beside our house so that we don't invite any kind of reptiles like snakes and all, because the essence of those acids, particularly I call this phenol as carbolic acid, since it produces a lot of very essence that it keeps the insects and the reptiles off. So the formula is C6H5OH. The structure of phenol is with the benzene ring with an OH. When the benzene ring with the OH is attached to a methyl group, we call this as orthomethylphenol, or better we call this as cresol. So cresol is a tribal name, is a common name, while orthomethylphenol is the IUPAC name. We can also have a compound called as M-cresol, what we call it as in IUPAC system as 1,2,3,3-methylphenol, or we can write here M-methylphenol. Similarly, here also we can write it as 4-methylphenol or para-methylphenol. In short, we call them in the tribal or in common name, we have it as para-cresol. Student, here we have something different, OH and OH. Here we call this as dihydroxybenzene. We call this as dihydroxybenzene, which is commonly known as quinol. So you might have heard nowadays we are going with some kind of tabs which is very important for the coronavirus, to eradicate the coronavirus. So chloroquinol. So this is the quinol which contains a chloro group. So this is the quinol with OH and OH. So dihydroxybenzene is called as quinol. And next to go, when we have this quinol on 1 and 4. So 1,4-dihydroxybenzene is called as quinol, but 1,2-dihydroxybenzene is called as catechol, while 1,3-dihydroxybenzene is called as resorcinol. So student, we have more than 2 OH even here. So if it is having 1, 2 and 4 trihydroxybenzene or hydroxyquinol, this is a common name for it. We have pyrogalol. So pyrogalol we use often in this chemistry while we deal with the different organic compounds. Pyrogalol, it is 1,2,3 trihydroxybenzene, and fluoroglucinolol or benzene 1,3,5-triol, we have 1, 3 and 5 trihydroxybenzene, and here we have the picric acid. The common name is of picric acid, or it is also called as 2,4,6-trinitrophenol. So you can see student, if this is 1, this is 2, this is 3, this is 4, 5 and 6. So you have on the second, fourth and the sixth position, 2, 4, 6, you have the trinitro, and this is what we call as phenol. So trinitrophenol or 2,4,6-trinitrophenol, together we call this as picric acid, and it helps us, like while we make cravings on the medical acrylates, we use this picric acid. And we have here salicylaldehyde or 2-hydroxybenzylaldehyde. 2-hydroxy, in the second you have the aldehyde. So here this is taken as 1 and this is 2. Now my question is, when there is aldehyde, when there is ketone and when there is acid, you remember you have to take those aldehyde, ketones and acid as a predominant factor with respect to the OH group. So here you have the student, this will be taken as 1 and this will be 2 because hydroxy is given less preference with respect to aldehydes, ketones and acid. So here we have the second, on the second position, the hydroxy, 2-hydroxy, and this is benzaldehyde. So if it happens that we have a benzene ring and attached to COOH and there is an OH here, how can we call them in the IUPAC system nomenclature? We have this as first, this is the second and this is the third. So if it come on here the fourth, we called it as on fourth, the OH group, this is the third and the fourth, we call this as 4-hydroxy benzoic acid. This is what we call salicylic acid. So student, here it is important that you know whom to give more importance when there is OH and aldehyde, ketones and acid. So this is salicylaldehyde. So if it happens that we go for the naphthol, in making the naphthol you require 2 benzene ring, and when this benzene ring is attached to the OH, remember this is the first position, this is the second, this is the third, this is fourth. If it is attached, if this OH is attached to the first carbon, it is called as 1-naphthol. If this OH is attached to the second carbon, it will be called as 2-naphthol and so on. So this is the first, if the OH is attached here, 1-naphthol. If the OH is attached here, it is called as 2-naphthol in this way. So student, we have now here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So when you have learned these 13 derivatives of phenol and its derivative, it will be easy for you to understand both the nomenclature in IUPAC system as well as in the tribal or the common names. Now we are going to deal about the structure of phenol. In dealing the structure of phenol, I would like to show you, this is the benzene ring and the benzene ring is attached to the OH group. Here the distance between the benzene ring and the oxygen is 136 picometer. But when we take an alkyl group with an OH, here this is methanol, this is phenol. So when it is an aromatic, it takes 136 picometer, whereas when we take an aliphatic or a CH3 group here, we have 142 picometer. So the distance between the carbon and oxygen in the aromatic is 136 picometer, slightly less than that of the aliphatic carbon with oxygen bond distance between 142 picometer. Here the angle forming is almost same, 109 and here 108.9 degree. What is the answer? What is the answer? Why it is that it's slightly less than that of the aliphatic? Because benzene is an sp2 hybridized carbon. So bonds to the sp2 hybridized carbon are shorter than sp3 hybridized carbon. So here you can see this carbon being sp2 hybridized, it is shorter in distance with respect to that very carbon which is sp3 hybridized. So I will ask to see you once more regarding the phenol, cresol and quinol, catechol, resorcinol and then hydroxyquinol, pyragalol, fluoroglucosinol, picric acid, salicylaldehyde and naphthol. Now we will go with the preparation of phenol. Is very less. Just learn 3 of the preparations. It is so nice and easy to remember. You too have done in the previous class regarding the preparation of phenol to some extent. So let us see. Here student, we have the benzene as C6H6. When we treat with concentrated HNO3 and concentrated H2SO4, what it happens is it forms C6H5NO2. So it forms nitrobenzene. So this is an ideal preparation of making a nitrobenzene. When this nitrobenzene is reduced by Sn plus HCl. So when you are adding tin with hydrochloric acid, particularly it should be dilute hydrochloric acid, it is going to produce enough amount of hydrogen. This hydrogen help in reducing it to form C6H5NH2. So it forms C6H5NH2. So here it forms 6 hydrogen. So what it forms is, together with that, it forms 2 molecules of water. So it forms 2 molecules of water. It is formed as a byproduct. What we require now is that when this C6H5NH2 is treated with nitrous acid, how you are going to make nitrous acid, student? We take NaNO2 plus HCl when we take between 0 to 5 degrees centigrade. From 0 to 5 degrees centigrade, when you take this aniline at 0 to 5 degrees centigrade together with NaNO2 and HCl, it produces HNO2. So what it produces? It produces HNO2. This HNO2 plus HCl, it helps in making C6H5N2Cl. So this is what we call it as benzene diazonium chloride. And benzene diazonium chloride, when you go for acid hydrolysis, that means when you add sulfuric acid in water and pass this benzene diazonium chloride, you get here C6H5OH. Together with it, like H will take the Cl and form HCl, and N2 will be in the form of a gas. So what you are getting is phenol. So student, this is an ideal way of making benzene. Either you are taking it from the N2Cl or from the aniline or from the nitrobenzene or from benzene itself. So if we give you questions on making the phenol from benzene, you have to start from here. Nitrobenzene, you have to start from here. If I ask you to start from aniline, you have to come from these 2 phases. And if I ask you to start from benzene diazonium chloride, this is a single step reaction. So this is number 1 preparation. This is number 1 preparation in making the phenol. But this usually we do in the lab. But when we think for something which is industrial process, which we require in a huge amount, because you know that phenol is in growing demand in the market. Why? Because it is called carbolic acid. It is used for some kind of disinfectant and also for using materials which are explosive. So industrially it is prepared by Doused process. Number 2 is Doused process. Doused process, Process, Doused process. What is that? When we take benzene diazonium chloride, so this is benzene, when we take benzene chloride or chlorobenzene, when we take chlorobenzene and treat with sodium hydroxide, so you can see, student, this Cl will be taken by H and it will be forming HCl. So you can see here this chlorine will be taken off by this hydrogen and form HCl. So ONA get attached to the benzene ring. And when this is again treated with dilute HCl, when it is treated with dilute HCl, what happens? This Na and Cl, they come out of the reaction, and together with it, the benzene is getting attached to the OH group and the phenol is formed. This is how we are going to prepare phenol industrially. This is by Doused process we can make phenol industrially. So students, you have to be very careful while you use this chlorine. So chlorobenzene with sodium hydroxide or potassium hydroxide, what it is happening is hydrogen chloride is formed together with sodium benzoate. So this way, together with dilute hydrochloric acid, it removes this NaCl to form the phenol. And third to go is from cumene, C-U-M-E-N-E, cumene. What is that? When we have a benzene, together with one propene, that is CH3, CH double bond CH2, and we pass it through phosphoric acid, H3PO4. When we pass it through the phosphoric acid, what it happens is, there is a benzene ring, and this benzene ring get attached to this CH3, CH3. So this benzene, like each and every vortex contains a carbon and a hydrogen. This is the structure for benzene. So this hydrogen, it elapses off, giving chance for this one propylene to come and add up here. And this hydrogen is carried back here, and this is what we call as cumene, C-U-M-E-N-E, cumene. And when we have this cumene with acid hydrolysis, what it is going to happen? Just check it here. So this is benzene, and this comes as CH3. Let us do like this. Let us first oxidize it. COOH and CH3. So when we oxidize it, it forms the COOH. Two oxygen gets added to this very carbon. And when we go for acid hydrolysis, now, what happens is the entire carbon is substituted back, and benzene OH group get attached to it, forms phenol, and together with it you get your acetone. So you get here a ketone called acetone. So CH3, COCH3, OH gets attached to the benzene ring, and phenol is formed simultaneously. So our process of making phenol is only these three. First is from benzene. Benzene, when we treat with concentrated sulfuric acid and concentrated nitric acid, we get the nitrobenzene. Nitrobenzene, when we go for reduction process with SNHCl, or you may also go with zinc and hydrochloric acid or lithium aluminum hydride. Any such kind of reducing agent can help in making the benzene adding up with the amine group called as the aniline. Aniline, when treated with NaNO2 and HCl at a temperature between 0 to 5 degrees centigrade, it produces HNO2 or nitrous acid. Nitrous acid with presence of HCl produces benzene diazonium chloride. Benzene diazonium chloride reacts with the water on hydrolysis with some acid. It produces phenol. Together with it, hydrochloric acid and hydrogen chloride gas and nitrogen is also formed, and they vaporizes, and phenol is left before. Now in the Gauss process, these two are from industrial process. These are industrial process, and this is a lab process. In industrial process, we require in a huge amount, but this is called the Gauss process. Here, chlorobenzene with KOH or NOH, when we treat it, but remember, this should not be aqueous, it should be anhydrous. So when we take anhydrous, any kind of strong alkalis, there the formation of ONA or OK, and then when we add dilute hydrochloric acid, we get the phenol. And finally, from the cumene, when we add one propene, this is one propene, PROPENE, one propene, when we add with the benzene in the presence of concentrated phosphoric acid, it is going to form cumene. Cumene on treating with when we are passing oxygen, and it forms such a compound which contains COOH group, on acid hydrolysis it turns phenol. So this is all about the preparation, and have a nice time ahead. Next time we are going to go with the physical and chemical properties of phenol in the next episode, which is coming very soon. Thank you so much.